Hello, Marauders. Hopefully you had some fun with the Pythagorean theorem. Today we'll look at the special case and learn how to break down those radicals. Okay, we're going to look at some graph paper here, and I drew some neat little triangles on here. We got this special case and says an isosceles triangle has two legs of the same length. You remember that. And if you have a right isosceles triangle, well, the angles are going to be 45 degrees, 45, and 90. In other words, like here's one right here. We know this is 90 right here, and since these are a tie, then these sides, these angles opposite must be a tie. These angles would be the same. So this angle would be exactly the same as that. And if this is 90 and a triangle is 180, and I subtract 90, that leaves me with 90 left over. And if I split it into two, then each one of these must be 45 degrees. Okay, so we call these 45, 45, 90 triangles. But here's some things. How long is this side? What about this? What about this? Here's a piece of graph paper. I put it on some graph paper. Each piece is 1 inch. So if I put this little triangle down here, and I can't seem to grab it, it won't let me off the screen there, and having all types of problems. Just grab, there we go. If I put it right there, I got part of it. How long is the diagonal piece? And don't say it's 1. It's not 1. This is 1. And this is 1. But doesn't this look farther? Yeah, that definitely looks farther. Well, how far is it? And we lost a little 1 right here. So let's try the Pythagorean theorem. We'll do the Pythagorean theorem. So let's see, we've got 1 squared plus 1 squared. 1 plus 1 is 2. That's not 2, it's square root. This side is the square root of 2. And I'm going to turn the page here. A diagonal on graph paper measures the square root of 2, which on my calculator is about 1.414 with a lot more decimals. So we're going to say about 1.4. And that makes sense. If this is 1 and this is 1, this piece is a little bit farther. It's 1.4. Let's go back to this piece for a moment. So what if I put this triangle on here? There we go. That came out really nice. Well, let's see. Didn't we say this little piece is radical 2? And this piece is radical 2? I got one here and here. Don't I have 2 radical 2? Yeah, I do have 2 radical 2. Huh. What about this piece over here? Let's put this one down here. I'll go over here. How many radical 2's do you have? There's 1, 2, 3. So if each one of these is radical 2, don't I have 3 times radical 2? Yeah, it's kind of a neat shortcut. There's 1, 2, 3. So it's 3 times the square root of 2. Of course, I can kind of go on my calculator and go, what is 3 times the square root of 2, which is too hard to see there. But it says about 4.2, about 4.24. Let's see how this works in reality. Let me actually check this out. Let me do the Pythagorean theorem to this guy. 3 squared plus 3 squared, 9 plus 9, 18 square root. Square root of 18, but we said the answer is 3 times the square root of 2. How do you get from here to here? These are the same thing because it says 1, 2, 3 of those radical 2's. But when I do the Pythagorean theorem, I get that. But if you check on my calculator, it is the same. When I put this in my calculator and go, let's clear it. The square root of 18, it says, well, that's 3 times the square root of 2. Oh, and I saw it if I did it on graph paper, which is 4.2. Yeah, if I did it on the graph paper, it actually works. But what if the sides were 4? 4 and 4, 4 and 4. Radical 2, radical 2, radical 2, radical 2. Isn't that 1, 2, 3, 4? Isn't that 4 times radical 2? But if I did the Pythagorean theorem and squared these, 16 plus 16 is 32, the square root of 32. My calculator says, oh, did you know the square root of 32 is 4 times the square root of 2? And of course, there it is, a decimal. Here's how we do this. Okay, we'll skip that, and we'll skip that. So let's just go back to this. Okay, the trick to breaking these down or simplifying radicals is you need to have the poster, which you can't see in the classroom, but I have this poster of all the square roots. You need to have this next to you. Copy it down, write it there. And this is how we break things down. Okay, let's say we would take the square root of 36. Now I know that. That's 6. But would you agree that 36 is 9 times 4? 9 times 4 is 36. So since these are both inside a radical, you're allowed to take them apart. The square root of 9 times the square root of 4. And I chose these because they're on my list. I could have said something else like 12 times 3, but I don't know the square root of 12 or 3. And then I go, what is the square root of 9? 3 times, what is the square root of 4? 2. 3 times 2, 6. Hey, you can do that. So if I had some things like square root of 9, square root of 16, square root of 25, square root of 100, what about the square root of 200? You go, square root of 200? How do I do the square root of 200? That's not on my list. So the teacher next year in Radical is going to show you this weird prime factorization tree. Remember those trees you go like this and break things apart? Don't do that. No. Everybody who does this method gets it wrong. Do not do that method, even though the teacher will show you that. Don't do it that way. Nobody in college does it that way. Here's what you do. You're going to go, what is square root of 200? My calculator, my Casio is going to tell me the answer. But here's what I do. I'm going to break it into 2 radicals. You have to pick something on the list, and it goes first, okay? So what you're going to put first is something on the list. You might say, well, can't I go 10 times 20? No, because you don't know the square root of 10, nor do you know the square root of 20. But what on here goes in the 200? Look for the biggest number first. 100. If you had $200, isn't that 2 $100 bills? So they're both radicals. I chose 100. I put that first because that's right here. I know the square root of 100 is 10. So I'm going to cross that out. Cross it out. Don't do it in your head. You'll do it wrong. I've graded thousands of these things. I've seen people do it wrong. That's 10. Square root of 2? I don't know. You leave it. And that's your answer. So this is called simplifying your radical, like you simplify fractions. And let's see if I am right. My Casio is so smart. And it's right. If you did as a decimal, there it is. 14. Yeah, makes sense. But 10 times the square root of 2 is the same thing. So you pick something on the list, put it first. Okay, let's try another one. You do 300. Okay, go ahead and try it. Pause the video. Okay, here it is. 300 is $300 bills. Put the one you know, put the one on the list first. This has to go first, okay? You know it, okay? The square root of 100 is 10. So cross out the radical and write a regular 10. Don't write square root of 10. The square root of 100 is plain old normal happy 10. 3? Don't know it. Leave that alone. So the one you know, change it. And that's your answer, 10 times the square root of 3. Mistakes I see people write, they write square root 10 square root of 3. No, the square root of 100 is not that. It's just 10. Okay, let's do one of the most famous ones. I want you to actually memorize this one. Square root of 8. Okay, break it into something. Okay, these are too big to go into 8. What times what is 8? So this is one we're doing right here. What times what is 8? What goes into 8? 4. 4 times 2. Put the 4 first. Got to put it first. Don't put it backwards. Do you know the square root of 4? Yeah. Change it to 2. Normal 2. Okay. Normal 2. Cross it out. It's a normal. This one, don't know. You'll actually memorize that one. It's the most popular one. 8, radical 8, simplified is 2 times the square root of 2. Okay. Let me give you another one. Radical 12. Okay. You think of it. Dargy, Tennessee, I think it's 6 times 2. Uh-oh, what did I do wrong? Oh, I don't know, square root of 6. Then I'm like, I don't know what to do. Start over. You have to pick off the list, okay? 4. In fact, most of your answers are going to be right in here. Mostly in here. 4 times 3. The square root of 4 is 2. 2 root 3. Pretty cool. Let's give you another one. 32. Now, 2 ways to do this. Okay, come up with your answer. Okay, some people said 4 times 8. Okay. Square root of 4 is 2. And they said 2 root 8. No. 4 root 2. Like what? You're not done. It's like if I said simplify 50 over 100 and you said, well, that's 25 over 50. Yeah, that's true, but can't you keep going? Oh, 8, are you done? No. Doesn't 8 break down? You'd be like, oh yeah. So this 2 is like that. This guy could have been 4 times 2. We did that before. And then go, this is a 2. Now I have 2 times 2. 2 times 2 is 4. 4 radical 2. Better way? I could have done it faster. What if I did this? What's the biggest number on my list that goes into 32? Is there a number bigger than 4? Too big, too big, too big. 49, too big, too big. In fact, get to about half of it. 16. Did you know 32 is 16 times 2? What's the square root of 16? 4. 4 root 2. Look, you did it faster, right? It's like somebody going from here to here and cutting out the middle. Okay, let's try something else. Let's get a little fancier because you guys are so smart. Sometimes there's a number in front, like 5 square root of 8. And you're like, well, it's just 5. What just says 5 times 8? There's nothing in between here, so it's always a multiply. Like when someone says 3x, you know what it means, 3 times x. This is 5 times the square root of 8. You never see that little dot. They just say 5 times the root of 8. Then you can go, oh wait, 8. I've memorized that, 2 root of 2. So it's 5 times 2 radical 2. So this is a regular 5. This is a regular 2. So just kind of go 8, 2 radical 2. Oh, there's a 5 in front. So I'll go 5 times 2. These are regular numbers. So you're going to say 10 radical 2. My Casio is so smart. It says 10 radical 2. But you got to be able to do it on paper. Okay, I think you got the hang of it. Okay, I'll give you one last one. Try that guy. Okay, pause it. Come up with your answer. Oh, this 10, he's just going to hang out in front. Did anybody go 9 times 8? Yeah. I did like this. I did 10, 36, and 2. 36 times 2 is 72. The square root of 36 is 6. So I have 10 times 6. 10 times 6 is 60 times the square root of 2. If you did it like this, you get 3. 10 times 3 is 30, square root of 8. And you're like, square root of 8 again? 30 times 2 radical 2. 30 times 2 is 60 root 2. Okay, feel so smart? Let's give you some work. Oh, and back to this. Remember these again? You might say, oh yeah, I forgot all about that. 5 and 5. Shortcut. If these are the same, remember about radical 2? 1, 2, 3, 4. Just go, if these are the same, you could shortcut your way to the answer. 5 root 2. You won't have to go 25 plus 25, 50. And then what do we do with 50? You were going, okay, 50. Oh, 50 is 25 times 2. Yeah. And what's the square root of 25? 5. The square root of 2? I don't know. What if this guy was 7 radical 2? That is the answer, isn't it? Oh, so these must have been 7s. Went backwards. I can get more complicated and fancy. Here's some that you could try. Take a look at them. Let me pause it. So you go ahead and try it. Pause the video. Okay, welcome back. Hopefully you got your answers. Don't just watch me for the answers. Check your own answers. If you didn't pause it, pause it. Okay, here's the answers. It's a tie. We can go like that. These are the ties. Oh, this is the final answer. And it says it's a tie. So these must have been 10. 6 radical 2. These must have been 6. Wait a minute, radical 6, I'm confused. Okay, so this is radical 6. So what's this? Okay, well, it's that side times the square root of 2. Do you think they're going to leave it like that? I mean, 8 and 8 radical 2. They're like, wait a minute. Since these are apart, you think you could put them back together? Radical 12. You're like, wait a minute. Could you break that down? Radical 12 is 4 times 3. The square root of 4 is 2 root 3. See, we can get really complicated. You can do an entire chapter on this. And here's the last one, and I'll talk more about this one tomorrow. Wait a minute. This looks like it's in the wrong spot. Well, it's possible. Isn't it possible this could be 10? Yeah, I could have a person right here, right? There's his hat. Couldn't that be 10? Well, remember you took this side and you times by radical 2. But now I'm trying to go backwards. What's backwards of times? Divide. This would be 10 over the square root of 2. And this is not considered simplified. I will tell you how to change that tomorrow, because my calculator, when I go 10 divided by radical 2, it says, oh, that's not a very good answer. 10 divided by radical 2. For right now, we'll just leave it. But here's what you see tomorrow when I try to leave 10 radical 2 and look like a multiple choice. It says 5 times radical. What? I'll tell you about that tomorrow. Okay, so let's see here. Okay, so once again, there's a picture of a worksheet for you to do. You can get a lot more complicated, and you can get algebra into this, and we'll do the last parts tomorrow, and I'll give you some review like this question right here. And I got some other cool problems like this for you tomorrow. But do the worksheet, take a picture of it. If you can't take a picture, then type in the answer. See you guys.